So we now have up next, we have Sarah Spencer, who's going to be talking to us about her fantastic machine knitting. And I think it's now an easy to say internet famous tapestry that she has here at EMF for us.
Good morning, everyone. Thanks for coming along. EMF has been close to my heart for a few years now. I went to EMF 2014 and I've been in love with it ever since. Now, this particular talk, I've actually had to cut it down a little bit. It was originally a 45-minute talk, so my apologies if I rush through a few things here and there. Mostly the Visible Knitted Universe tapestry is actually right at the end of the talk, so I really want to just get along to that because I think a lot of you also want to hear about that as well. But most of this talk is actually about the technology that made the tapestry. All right, so let's get started. I hacked a domestic knitting machine for the 1980s and I turned it into a network printer. I know that sounds completely ridiculous and you're probably used to that after a couple of days here at EMF, but bear with me and I hope I will have convinced you that that's exactly what I did, but happy to hear from the audience for how you think I went. Right, so how do I define a knitting network printer? So it needs to accept an image from my computer over the network with more than 2 colors in any single row. So me personally, I'm not a big fan of black and white printing. I like to print in color. And it can knit hands-free mostly. So this is a really old piece of tech. It comes from the 1980s. It's interesting to try and modify, and there's certainly, and yarn itself is quite a fuzzy material to work with, so things don't always go according to plan, which is why I'm like, okay, well, it mostly does what I claim that it does. Right, so chapter 1, standing on giants. Who here has actually seen a knitting printer? Sorry, a knitting machine? Ooh, a good chunk of the audience. I want to say about 40% roughly, which is fantastic. How about in real life? Have you seen one in real life? Excellent. Yeah, about 35%, which is so fantastic. So I don't need to spend too much time right now on going through the technicals, but basically this image shows you what a knitting machine actually looks like. We've got like a bed of needles. So you know, traditional knitting needles, you have 2 needles and you pass the knitting from one needle to the next. You turn it around, you pass it back again, and that's knitting. This machine, however, it has 1 needle per knit. So that zoomed in graphic that you can see with the needles passing along. So you've got a carriage and the carriage pulls the needles out to collect the knitting and then it pushes them back in again and then they come out, pop out again. That's actually what does the knitting. So because it manipulates multiple needles at once, it can actually do it really fast. So I think that's kind of the main difference between traditional knitting needles and a machine which uses 1 needle per knit. And these machines are typically about 200 needles wide, so you can do about like 200 needles worth of knitting, or 200 knits wide. Right, so this is actually really hard work. So this video is the lovely Lorna Watt, who's demonstrating a particular technique called intarsia knitting, and she's using her knitting machine here. So I wanted to show you this because I want to emphasize how much work using these knitting machines are. It's a bit like a sewing machine in the sense that you sit there and you have to engage with the knitting machine in order to produce knitting. So it is considered a handcraft, even though you're using a machine to simplify some parts of the tasks. Other things can be greatly complicated by having over 200 needles. If you're using a ribby, then there's actually 400 needles. Yeah, so it is a handcraft, and I had the crazy idea about automating this, which is a little bit nutty. I'm not going to spend too much time on this slide, but basically I wanted to emphasize that these old knitting machines, they originally started being built in 1955, or the Brother range specifically, the Brother brand, and they stopped making them in 1996. I think that was the Brother 970. That was the last machine they ever produced. Basically, the industry changed, and people just weren't buying knitting machines as much anymore. It was just so much cheaper and easier to just go out and buy your knits without having to make them at home. Yeah, the industry changed, so they aren't being produced anymore. So there's a huge variety. In terms of hacked knitting, there's a huge variety of different machines, all the way from purely mechanical to electro knitting, which actually has an onboard computer. Yeah, so there's a bit of a lull in the actual history of knitting machines. And then in 2007, there's this incredible server hack, which I'm going to show you in a moment, by a pair of Berlin art students. And then from there, we actually see a whole bunch of other hacks coming in on these old knitting machines. Specifically the electro range. We have an Adafruit hack, a YAB shield, which is incredible, basically replaces the onboard computer. And then the Knitterate. Has anyone here heard of the Knitterate on Kickstarter? Yeah, we've got a couple of people. How amazing is that machine? So Knitterate is a whole new domestic knitting machine, which was produced by a team who tried to start an open source knitting machine project, but because the hardware is so specific and needs to, or is so intricate that it needs to be produced in a factory, they couldn't actually make it open source completely. So yeah, Knitterate, amazing machine, really, really cool. Right, so this is the Gelsomnia by a pair of Berlin art students, Magdalena and Hannah. I don't actually know very much about this. I can infer from the photo that they've taken an old mechanical impizial machine, which has a punch card system in it, and then you can see these silver devices are servos which are reaching into an old punch card system and manipulating the punch card as it goes, which is fantastic. This is the only hack that I've seen out on the internet anywhere that actually hacks a purely mechanical knitting machine. I have a purely mechanical knitting machine at home, haven't managed to hack it yet, so I would absolutely love to find out more about this if anyone else can speak German and help me search for it. But the actual hack that I use today is based on the Adafruit hack, which is the core part of the hack was actually written by Steve Conklin with help of Lee Morfrieda and Becky Stern. So Steve actually wrote a Python floppy drive emulator. And this Python floppy drive emulator, if you use a hacked FTDI cable, can plug directly into the old floppy drive port on the Brother 930 knitting machine. So the original floppy drive port, the intention was you draw out your knitting pattern onto a mylar sheet, basically a piece of paper. You scan it into the onboard scanner on the knitting machine, and then you can save, so you can back up your patterns onto floppy drive and recover them again. But I mean, why use the onboard scanner? We can just talk directly to this old floppy drive port and upload patterns that were never originally, part of the scanning process, which is absolutely brilliant. That's something that Steve Conklin built that part of this hack, which is absolutely incredible. Right, so with Python, we can now create an image, and it can be converted into a knitting pattern and then upload directly onto this very old knitting machine, the 930. And that's the URL for it. At about this stage, so we're talking roughly 2013 now. This is when I'm like, this is so amazing, this is incredible, I need to get into this. And I found by complete coincidence on the London Hackspace wiki, they had documented that they have a Brother 950 knitting machine. And it's just the documentation, it's in this location, you can find it here, these are the maintainers. I'm like, you guys are awesome. I jumped onto the RC channel. I'm like, do you mind if I come along and just hack your knitting machine? They're like, sure, why not? Come on in. And I'm like, oh, you guys are so cool. So mad shout out to the London Hackspace who actually got me into all of this in the first place. Really amazing group of people. So this is me taking the Adafruit hack and using it on their Brother 950 knitting machine. You'd think, so the original Adafruit hack from the US, it was on a 930 knitting machine, and then the one that we had at the London Hackspace was the Brother 950 knitting machine. Now you think 930, 950, they must be quite similar. Surely the hack would just, work seamlessly, and not really. The 930 knitting machine is a 16-bit knitting machine, and the 950 is a 32-bit. Quite different. It took me a little while to figure out how to modify the hack to get it working on a 32-bit, but I did in the end. And this is one of the very first things that I knitted from my computer. So you can see the graphic there on my computer. And the computer is connected using hacked FTDI cable, which I believe Charles Yarnold actually hacked that FTDI cable for me. So shout out to Charles, who's in the audience today. Yeah, so that was my first actual print, if you will. Right, so this is my modification of the original hack that works for the 950, or specifically the 950i, but 950 and 950i are similar enough. Right, so first point, can accept an image from my computer. Check, yeah, I think I managed to do that, so that's good. Right, over the network. Anyone here heard of Octoprint? Octoprint for 3D printing. Yeah, we've got a few hands going up, about 10 I want to say, roughly. So Octoprint is a web interface that is effectively designed to be an interface to send your files through to a 3D printer. I quite like the implementation of it, how you can modify, tweak it. I'm pretty sure there's a preview feature as well. You can do all these really cool things before you actually send it through to a 3D printer. So I created OctoKnit. So OctoKnit is a web interface that is sitting on a Raspberry Pi, and the Raspberry Pi is the thing that is connected to the floppy drive port on my knitting machine at home. So now I don't even have my computer connected to it anymore. I can be in a completely different room. I can set up an image. I can send it to OctoKnit, and it can I can preview the graphic in the actual knitting grid before I get the knitting machine to start printing it. So OctoKnit is the web interface for it, and this is where OctoKnit lives today. So that's the Raspberry Pi connected to my knitting machine. And that's my source code for it. So it's now working over the network, which is nice. Right, so not just black and white, and this is where things get quite interesting. So when I was at London Hackspace, I was running some tutorials for people to teach them how to actually work with these old knitting machines. And I created some samples. So I was particularly interested in multicolour knitting, or in these samples in particular, two-colour knitting. So I was actually learning about knitting and learning how to knit, and at the same time I was trying to hack this knitting machine, which is blew my mind in a few places. So here's some samples that I made for the London Hackspace. I don't know if they still have them anymore, but they were kicking around a few years ago. So these are 4 examples of ferrule, intarsia, double jacquard, latched ferrule. So they're just different techniques of knitting two-colour. But in the front, they look very, very similar, and this is the thing that I want to point out, that they look similar from the front, but in the back, it's a wildly different story. Ferrule in particular, it works quite well for two-colour, but when it comes to three-colour, on a knitting machine anyway, there's a lot of hand manipulation and it gets quite complicated. Same for a latched ferrule, and intarsia is probably the most complicated of the lot in terms of trying to get it to work on a knitting machine. So there's a lot of hand manipulation. Now I'm trying to automate this process to simplify it. Excuse me. So the particular technique that I was quite fond of is double jacquard. And double jacquard is double layered knitting. So you've got knits in the front and knits in the back, and the purls are in the middle, for anyone familiar with the knitting terminology there. So 2 layers. So you actually have one picture on the front and a completely different picture on the back, which is really awesome. So we don't have to hand or float yarn that's not being knit into the front. In another technique like ferrule, it'll be floated in the back, which is just a strand of yarn, which is okay if you have really short strands, but when your strands get quite long, they can get tangled, they can start pulling on the knitting, and the knitting can actually start falling apart, which isn't good. So I was quite fond of double jacquard, and not just for the reason that it's nice and neat and clean, but also because it really simplifies the process. So this is me doing double jacquard. So at this point, we've got the network part, and this is the actual knitting by hand. So you can see that there's 2 parts of this process. There's the left and right motion, and then there's the button pressing. Left and right, and button pressing. Compared to the video they showed you earlier of Lorna Watt knitting the intarsia, this is a lot closer to being possible to automate, which is what really excited me about this. So double jacquard, loved it. Now the other cool thing was the knitting machine was always possible to do multicolour knitting, to do more than just 2 colours. The patterns themselves actually supported it. And in this card that you can see just on the right-hand side, you can see numbers, and those numbers change. You got 1, 1, 1, 2, and then 1, 3, then 1, 3, 4. So it could always support multiple colours. But what I really know, in particular, what I noticed about the original Adafruit hack was it didn't support multiple colors. So when Steve Conklin and Lee Morfreda, when they were looking into this, they never completely reverse engineered the file format for these old knitting machine patterns. So they never quite worked everything out. So just with a process of hacking it and trying it and see what changing things and seeing what happened. Reverse engineering. I worked out a few things like how to change the width and the height. So the original Mylar sheets were essentially 60 pixels wide and 150 pixels tall. But the knitting machine can support a variable width and height. So that was one really cool thing that really helped me. And that actually turned out to be a really important step to find out the next thing, which is this MIMO field, which was always blank in the original hack. And this, I'm pretty sure this comment here, if I can read it out to you, I'm pretty sure the comment was written by Steve saying, "The MIMO seems to always be blank. I have no idea really." And I noticed that it was always the same length as the number of rows in the knitting. So there's always the same size as the number of rows in the knitting. And that's where I'm like, oh, I know what that's useful for. The color integer, that's where we store the color integer. That's how the knitting machine knows what color it's supposed to be for that particular row. So I was super excited about that. That was a major epiphany moment for me. That was a big turning point. I think it's circa 2014 this stage. Right, so that's where I could work out that given an image and given knowing what color we're doing in each particular row, I modified the hack again to support this color integer. And and I managed to knit out the more than two colors successfully. Something else that I should probably point out is that the actual knitting itself, the limitation of only having one color changer on one side means that you have the color in the carriage, you go all the way from the color changer to the other side, so you've started knitting on that row, and then you have to return to the color changer before you can actually switch colors again. So it actually has to knit up and then knit back, which means that in all of the patterns that were originally designed for the Brother 950i and any previous knitting machines, it always had double height. And I can show that to you in that previous example here. It always doubles. So you got 1, 1, 1, 1, 2, 2, 1, 1, 3, 3. It's always doubling because it always has to return to the color changer. And in order to get that to look like a pixel, to look like the images that I had on my computer, I also had to double the width as well. Which I found really, really quite frustrating. I wanted 1 knit per pixel. That's what I wanted. That was the thing I really was quite passionate about. So at this stage, I think we're must be 2016 at this point. So I'd returned home from London. I only had a 2-year working visa here. I'm an Aussie, by the way. Returned home from London, got married, had a kid, and this is the thing that was just sitting in the back of my mind, going, we need to fix this, we need to solve it, we need to make it happen. So one thing about having a newborn is, of course, that you spend a lot of time awake, your hands are full, you are physically exhausted, but your mind doesn't really get exercise much at all. So I found that I spent an awful lot of time thinking about this problem. I had my hands were full. I couldn't actually do any typing or do any testing or anything, but I thought about it. And this is what I came up with: 4 different potential solutions to this particular problem. And the computer scientist and me thought, well, let's just do them all. Let's just program all of them and see what happens. And this is the output. So the original one we have here is 4 knits per pixel, so that's that one. And then, just to skip through a little bit, what I call the offset method. 1 knit per pixel, and the elongation problem is somewhat reduced, which I'll explain that every time you do a pass of the knitting carriage, you have to knit into the back because it's bird's eye. And I won't go into that too much, but the more you knit into the back and don't knit into the front, the longer the piece gets to try and counteract the number of rows in the back that aren't in the front, which is actually pulling on the whole piece. So it resolves this by actually just elongating the problem, or elongating the piece. And this offset method I was most happy with. So 1 knit per pixel. This is something that no one else had previously done in this space before, using more than 2 colors. I did actually go onto some knitting machine forums and sort of, I did a big blog post on this, on how it works and how you can do it. Like you can actually test the theory on a knitting pattern sheet and scan it into the knitting machine. If you haven't already hacked a knitting machine, you can still test this idea. Most people are quite confused by it. I did get feedback from one crowd who released commercial software for these knitting machines. Yeah, the main feedback from them I got was, it's interesting. Doesn't work though. It's not possible. It's right here. I've done it. It's physical. I've done it. Anyway. There's the back, because I'm a knitting machine enthusiast. I always show the back of my work, so that's the back. Done in double jacquard with bird's eye backing. And just a small comment on 4-color. There's Gizmo in 4-color. I don't do too much 4-color because with that many rows in the back that aren't in the front, it's actually starting to bulk up the knitting a fair bit. It looks okay when you look at it in a picture, but if even you want to come up here after my talk and want to feel some of this fabric, yeah, 4-color just doesn't quite feel right as a fabric, although it looks all right. So I have tried 4-color. All right, so excuse me. So there's my code. I've updated my code again, so feel free, if you're at all curious about hacked and knitting machine worlds, you can download that and have a play with it. I believe the AYAB hack, which is the completely replacing the onboard computer with what I believe is an Arduino based machine. I believe that they've actually started incorporating this new 3-color knitting pattern theory. So I believe you can actually produce my algorithm on their machine now, which is awesome. Right, so more than 2 colors in any single row. After all of that, do you reckon I've done it? Yeah? All right, sweet. That's a relief. Okay, moving on. Hands-free, mostly. Right, so I didn't actually reinvent the wheel this time. I just went out and bought a Brother Motor K100. They're expensive, so you have to be really committed to jump into one of these. I did actually want to make my own motor arm that would reach down and do the actual side part or side swiping for me. But I've got a toddler, so it's my excuse. But the automatic color changer. So I did mention earlier that we have 2 particular actions that were between me and getting an automatic knitting machine. So one was that side swiping, which is replaced by a Brother Motor arm. And the other one, I have to admit, I went to my husband, who's really quite amazing in the world of hardware hacking. I went to my husband and asked him, hey, can you automate this button pressing for me? And he took one look at the problem and he's like, nah, can't be done. A couple of days later, he came back to me and he's like, oh, no, actually, yeah, I can. I've already done it. So this is his GitHub repo. He's actually got, he's got not just the code for this hardware device that he's created, he's also got instructions on how to build one, which is awesome. So I've been getting a lot of requests saying, hey, when are you going to sell them? When are you going to sell them? When are you going to sell them? I'm like, eventually, but you can just actually build your own. Yeah, so big shout out to Major. Really, really cool piece of tech. So putting it all together, this is a time-lapse video. So this is where I say it's mostly automated, so I still need to cast on. For any hand knitters out there that appreciate the casting on process is quite frustrating, no matter what part of the knitting world you come from. But yeah, the nice thing is I can actually walk away from the knitting, which is pretty much my goal. That's really what I wanted to achieve, which is good fun. I do still have to come back roughly every 100 rows or so because the knitting is coming down underneath the knitting machine and it's being held down by weights. So after about 100 rows, the weights are getting close to the floor and I need to come back and move them. I'll try and automate that one too for you. Right, so this particular knit actually was completely flawless. It worked beautifully. Then I came back and moved the weights. It worked beautifully, except the device I was using to take the time lapse, it ran out of battery. So you just have to trust me that it worked. There we go, cut out there. And also the casting off process looks very similar to the casting on. So I just have to, for each needle that's holding a knit, I just need to close it off and finish it up. So this is the piece of that I was knitting that particular day. It's a tessellated rocket scarf, MC Escher style. Good fun. Right, can hit hands-free mostly. What do you reckon? Did we get there? Yeah? Sweet. Okay, so I've got 3 minutes now to talk about the universe, so I'm going to speed up my talking even quicker. These are other things that I've done previously, so I've done more than just the universe. Feel free to come talk to me about them afterwards. Right, so, my goodness, I tweeted this on Sunday, and it got, since last Sunday, so a week now actually, now that I think about it, it got 14,000 retweets and 72,000 likes on Twitter. Wow. That was overwhelming. Amazing outpouring of love from the internet community, which is absolutely incredible. I've never done anything that anyone's liked that much before. So amazing. So this piece was actually part sponsored by EMF Camp. It wouldn't exist without EMF Camp. I really wanted to emphasize that. So the blue yarn and the white yarn was paid for by EMF Camp, but I was a little bit too ambitious and I made it too big so that EMF Camp couldn't actually afford the grey yarn, and that's fine. So what you're seeing here is a picture of the visible universe that we can see with the naked human eye. So it's all 88 constellations. Across the top, we've got the constellations in the northern hemisphere. Across the bottom are the constellations in the southern hemisphere. There's the equatorial line that's through the center, which is basically the equator of the Earth projected out into space. So you can get a sense of what part of northern and southern hemisphere you can see. The grey cloud is actually a representation of the Milky Way, and we've also got the sun, the moon, and the planets in this particular piece. The stars have been scaled according to their luminosity or magnification, actually. Humans can see up to magnification 5 or 6 with the naked eye comfortably. That's how you can see that this piece shows up to magnification 5. So it's really the visible universe according to the naked human eye. The planets, I actually designed the planets to line up to a particular date and time, and they lined up at 6 p.m. Friday the 31st, the day that EMF opened. Way to hit a deadline. So there's 88 official constellations out there. There's actually 89 which have been labelled in this piece, and that's because Serpens constellation, the one and only constellation out of them all that is actually split into 2 non-contiguous parts. So Serpens Quarter and Serpens Caput have actually been labelled separately because it's non-contiguous. So that's why there's actually 89 constellations on this map. I just want to emphasise that. It's been knitted using locally sourced Australian wool close to home, so it's essentially 100% Australian made. And because of that, I gave one constellation in this star map its modern name, and that's the Southern Cross, which can be seen on the Australian flag. I should emphasise again, I couldn't have done this without the help and support from my husband. I've been working on this for a couple of months now, and it's been pretty much every single weekend for several months trying to get this piece finished for EMF Camp. So big shout out to John Spencer, he's been absolutely amazing. And surprise, it also lights up. So I took this, oh, by the way, I'm actually one minute overdue now, so I'm trying to talk really quickly. I took the star map to a hackathon at my workplace, REAIO, where I work is realestate.com.au. And I got a team, an amazing, incredible team of 18 people, and we like designers, front-end developers, back-end developers, system architects, and we got together over 3 days. We built a website that talks to an AWS Lambda service, that talks to an AWS IoT service, that lights up neopixels in the knitting, which is controlled by an ESP32. So incredible. But only 8 of the constellations light up, so eventually I would love to finish it and light them all up. But yeah, so you can actually see this piece in this tent. Look for this tent. It is the lounge, and you'll find it in there if you want to go have a look. That's it.